curve between B and H. It is the curve between
B and
B and H. What is B? B is your magnetic flux density, and H is your what? H is your magnetizing force. Yes or no? H is your magnetizing force or magnetic field intensity. Clear? Now, what is the relation between B and H?
equals mu H.
B is equal to mu into H, where mu is the permeability and its formula is equal to mu 0 into mu R. Okay. Now here I want to tell you that when a magnetic material, suppose I am taking a magnetic material, this is a magnetic material, listen to me carefully. This is very important, you will get as a long question. Okay. See, when you are taking a magnetic material, when a magnetic material is subjected to one cycle of magnetization, when a magnetic material is subjected to one cycle of magnetization, one cycle of magnetization means what? You will pass a current first in one direction, okay, then you will reverse the current and you will pass a current in the other direction. Okay, listen to me all of you very carefully. Now, when you will pass a current, when a magnetic material is subjected to one cycle of magnetization, that means you have to pass current in first one direction, then another direction. Okay, so what happens when you are passing a current in one direction? There are molecular magnets which are arranged in an haphazard manner. Okay, not in orderly manner, North Pole, South Pole, like this. They are arranged in an haphazard manner. So when you are passing a current in the conductor which is wound over the magnetic material, this is nothing but my magnetic material. Okay, this is nothing but your magnetic material. So when I am passing a current in a coil which is wound over this magnetic material, the molecular magnets, these are molecular magnets or the domains, magnetic domains, they will be arranged in an orderly manner. North Pole, South Pole, like this. North Pole, South Pole, like this. So what will happen? You will get a complete North Pole here. This one is your South Pole. And magnetic flux will emerge from the North Pole. It will enter and the South Pole. This is how the magnetic flux is created by the help of, this is nothing but an electromagnet. You are passing an electric current over a magnetic material which is wound over a magnetic material. So when you are passing a current, what happens? Inside the magnetic material, there are molecular magnets. They are arranged in an orderly manner. So magnetic flux will emerge from the North Pole and it will enter at the South Pole. Obviously, they will not be intersecting each other. Am I clear up to this?
Yes, ma'am.
Yes, ma'am.
Okay. So now here coming to the BH or the hysteresis loop. When a magnetic material is subjected, I will write down point wise. When a magnetic material is subjected to, write down. When a magnetic material, just wait 1 second. When a magnetic material is subject, write down. I am detecting. When a magnetic material is subjected to one cycle of magnetization, when a magnetic material is subjected to one cycle of magnetization, it is yes, when a magnetic material is subjected to one cycle of magnetization, it is found that P lags behind H. Lags behind H. Okay. when a magnetic material is subjected to one cycle of magnetization, it is found that B lags behind. One cycle of magnetization means one cycle of magnetization means first the current will be given in one direction. First current is given in one direction and then in the other. Okay, you will tell that the magnetic material is subjected to one cycle of magnetization. That means here you can conclude that here you are telling that the first is current is given in one direction, then in the other direction. That means when a magnetic material is subjected to an AC current, understood or not? When this means what? The current is reversing means this is happening in which direction? The current is unidirectional in the case of DC. So this will happen only in case of what? When a magnetic material is subjected to an alternating current, because alternating current, the direction is reversed. Am I clear to all of you?
Yes, ma'am.
Yes, ma'am.
Okay. Now coming to the third point. So we will see that what happens when a magnetic material is subjected to one cycle of magnetization. Okay, so here I will draw the curve. You draw it first, then I will explain. This is O, A, this one is B, this one is C, this one D, this one E, this one F. This one is your plus B maximum. You write down, then I will explain. Done it?
No, ma'am.
Yes, ma'am.
So you know that the equation is B is equal to mu H. Another equation you know that H is equal to Ni divided by L. Okay. So now here I will be explaining you, if possible you write down in notes or else you will make your own notes. Okay, I will explain all this process within 6 points. So those 6 points you will make it, if possible I will be repeating more than once, but I will not be writing because this is completely a theoretical part. I will not write it. You write it in a points, understand, you write in your own words, okay, or else you write whatever I am telling you. Okay. Now here you see one, when your H is equal to 0, tell me, neither N or L. N is what? N is your number of turns, right? And what is your L? L is your length of the conductor. Understood or not? L is your length of the conductor. So when a magnetic material is having n number of turns, L is the length of the conductor. H will only be 0 when current is equal to 0. H is 0 only when I is equal to 0. Yes or no, tell me. Okay.
Yes, ma'am.
So first point is when H is equal to 0 means when H is equal to 0 implies B which is equal to mu into H, that is equal to 0 also. So H is equal to 0, B is equal to 0. So the curve starts from what? Curve will start from
Origin.
origin. Very good. Curve starts from origin. First point is clear? Okay.
Yes,
Anybody is not clear, tell me. Anvay, you are clear?
yes, ma'am.
Okay, very good. So the curve is starting from origin. Look at the BH curve. It starts from origin. This one. Now come to the second point. Second point, your as the current increases, what happens to your H? H will also increase. H which is equal to Ni divided by L, that will also increase. Yes or no? H
Yes,
which
ma'am.
is equal to Ni divided by L, that will also increase. B which is equal to mu into H, this will also increase, right? Okay, so the curve is increasing with the increase in the current. Written here, look at the curve. I have to move the board here and there. I have to explain this one. Okay, so here you see as I'm, yes, this is your, sorry, I'm extremely sorry, I'm not written. This is your H. X-axis is your H, Y-axis is your B. This one is your minus H, this one is your minus B. You are drawing the, or you are finding the curve, BH curve. Okay. Now here you see, as I'm increasing the current, here H is equal to what? Ni divided by L. So here as I am increasing the current, here I am increasing the current is increasing. So what happens to my B? I am getting from the second point that B is increasing, because when I am increasing the current, H is increasing, so B is increasing. So the path will be shown by which one? OA. Am I clear to all of you?
Yes, ma'am.
Is it clear to all of you or not? Tell me.
Yes, ma'am.
The path is given
Yes,
by
ma'am.
teacher. Yes, here you just mention path is what? OA. Clear? All of you are clear? Coming to the third point. So as B increases, it becomes maximum at, it becomes maximum. When it will become maximum, tell me? As B is increasing, as current is increasing, your H is increasing, B is increasing. As B increases, it becomes maximum at what? Plus B maximum. Okay, why there is a maximum? Because the poles become saturated at this point. Why the poles become saturated? You take a magnetic material, you will pass a current, you will increase, you will go on increasing the current, no doubt the H will increase and B will increase. But B will be maximum at a certain point. Why? After that it will not further increase. Why? Because when all the magnetic materials or the domains will be arranged in an orderly manner, when all of the molecular magnets will be arranged in an orderly manner, then even if you are increasing the value of the current, even if you are increasing the value of the current, B will not further increase. B will be maximum at that point. Am I clear to each one of you? Got it?
Yes, ma'am.
It becomes maximum at plus B maximum, as after that the poles become saturated. I am writing only the key points. Poles become saturated. So I was supposed to not write there, but poles become saturated and B will not further increase. B will not further increase with increase in what? With increase in
Current.
current. Very good. Increase in current. Clear? So after the next, come to the fourth point. Come to the fourth point. If current decreases. If I decreases, H will also decrease, B will also decrease. B decreases, but it does not follow. It does not follow the path in which it has increased, all of you understand and write, huh? rather it will follow another path. You write down bit quick with me. It will follow another path. What is that another path? Let us find out. I have told you, see, if I will decrease the current, I have got a maximum flux density. After that, if I am decreasing the current, H is decreasing, B is decreasing. But here you see, it does not follow the path in which it has increased. In which path it has increased? What was the path?
OA.
OA. Very good. OA was the path in which it has increased. But if there is if you are decreasing the current, it will not follow the path OA or the path in which it has increased. Rather, it will follow a different path. Look at here. It will follow, if I am decreasing the current, it will not follow this OA path. It will not decrease in this particular path. Rather, it will decrease in which path? This path. Understood, all of you? Anybody having doubt, you unmute and ask. Okay. So what is that path? Tell me. Path is your
AB.
AB. Very good. Another path is your AB. Okay. At B, what is your at small b? At small b, what is your capital B? Tell me. B is equal to 0. B is equal to 0. What is the current at that time? Look at the curve and tell me. What is the current at B equal to 0? At B. At B, B is 0. What is the current at that particular time? I is equal to, look at the curve and tell me.
0.
Yes, current is equal to 0. B is equal to 0. Huh? B is equal to 0 at B.
No, ma'am.
Tell, what is the value of B? B, I am having this. B is having a finite value. Yes or no?
Yes,
It
ma'am.
is having a finite value that is equal to how much? PR. Have I mentioned PR?
Relatively.
No, that is,
No, ma'am.
I think you have read it in your 12th standard, something. Yes or no?
Yes, ma'am.
This is your residual flux density. Even if the current is 0, you see here the current is equal to 0 at this point because H is 0. But you are having some finite value that is called as the residual flux density. Sub-generator motor is due to this one. Due to the residual flux density nature of a magnetic material, we are able to use these generators and motors very easily. Okay, even if current is not 0, you are having some finite value of flux density. Okay, so B is having a finite value called which value? BR. That is called as residual what? Flux density. Why it is called as residual? Because current is equal to 0, but we are having which one? We are having a finite value. Am I clear to each one of you? You write down in your words. ऐसा नहीं कि मैडम जो लिख रहे हैं रट करके लिख देंगे. मैं जो whatever I have written, if I will see those exact words you are writing in your copy, I will also cut mark. Write in your own sentence. Okay. ऑनलाइन में हो मैडम का बोर्ड देख करके जो लिखे मैडम लिख लोगे नहीं. Write in your own sentence whatever you have understood. Okay. And write down properly. So here you see you are having finite value. Clear to all of you? Now, coming to the fourth point. What was it? The fourth or fifth point?
5th.
Ma'am, 5th point, ma'am.
Okay, very good. So coming to the fifth point. Suppose I at fifth point, I am having current equal to 0, but I am having a magnetic flux density as a residual flux density. So to wipe out the residual flux density, what I have to do? To wipe out the residual flux density, a magnetizing force is applied or a current is applied. Magnetizing force means what? Obviously, magnetizing force is your H, right? H is equal to Ni divided by L, or you have to pass a current in the reverse direction. To wipe out the residual magnetism, a magnetizing force or a current is applied in which direction? Tell me. Current is applied in reverse direction. Okay, in reverse direction. Here at that time, current is negative. Current is negative. Look at here. Current is negative or not? Let us see from the graph. Where is my paper? Here you see. After this point, here you see, after up to this, I am having the residual flux density. Here you see, here H is negative. Yes or no? After this, H is negative. So we are current is negative means we are applying a current in the reverse direction to wipe out the residual magnetism. Now here you see at this point, what is my B? Is there any value of B? Is there any value of B here at this point?
No.
No. So that means I have completely wiped out the residual flux density. Okay, I have completely wiped out the residual flux density by applying a current in the reverse direction. And the force we are applying, that is called as coercive force, HC. HC is negative in this direction. Am I clear to each one of you? All of you understood? All of you understood or not? Tell me.
Yes, ma'am.
Okay. So I or a current is applied in reverse direction. So path is which one? Path is AB or BC? What?
BC.
Path is BC. At C, B is equal to 0, but H is having a which value? A negative value. Okay, that is called as minus HC, or is called as coercive force. Coercive force, suppose you will get a short question. Define coercive force. How will you define it? How will you define coercive force? It is the force applied to wipe out the, it is the force. Are all of you writing or not?
Yes, ma'am. We are writing.
Yes, ma'am.
Okay. Force applied to wipe out what? Residual magnetism. To wipe out residual magnetism. Okay, this is all about number 5. Clear? Now coming to the number 6 point. Number 6 is written, all of you?
Yes, ma'am.
Now come to, where is my graph? Yes, now come to number 6 point. Number 6 is, here you see, if I will increase the current in the, I have already passed a current in the negative direction. If we increase the current in the negative direction, if we increase the current, because I have told you, when a magnetic material is subjected to one cycle of magnetization, you have passed a positive current, now you are passing a negative current. Now, if we increase the current in the negative direction, if we increase the current in negative direction, then I am increasing the current, H will increase in negative direction, okay, and B will also increase. Okay, and will become what?
Constant.
No,
Satu-
constant means the
saturated or
maximum. Saturation. Yes,
yes,
very good. Becomes maximum. I am telling that as maximum. Maximum means minus B maximum. Here I have shown you. I think I have shown you. Yes or no? Yes,
Ma'am,
I
shown.
have shown you.
yes,
This
ma'am.
is your minus B maximum. Minus B maximum means इधर उधर हो जाएगा. Here this one will be your south pole. This one will be your north pole. Yes or no?
Yes, ma'am.
Got it? So here.
Can you show the sixth point?
6 point, yes, we write down. If we increase the current in negative direction, H increases in the negative direction, B will also increase in the same negative. Okay, and will become maximum at B maximum. Path is what? What is the path? Tell me. What is the path? Tell me.
CD.
AD.
CD.
CD. Path is your CD. Okay. Now last point, seventh point, last point is when we increase the current in the positive direction, the path is completed. Path is completed. What is the path? D, E, F, A. Okay. Then again what you will do to wipe out this, again you will pass a current in the positive direction. Then what will happen? There will be a residual flux density. That will be minus BR. Okay. Then what will happen? After that you continue, you increase the current in the positive direction. You will see the path is complete with EFA. Am I clear to all of you? Understood?
Ma'am, एक बार फिर से.
Up to here you see. Now what we are having? We are having a minus B maximum in the negative direction. Negative means I am passing a current in which direction? I am passing a current
North
in
to south.
no, yes,
North to
I am
south.
passing a current in this direction. You know, according to Fleming's right hand rule. So this will be north pole and this one will be your south pole, right? So I am having a maximum flux density because I have passed the current and all the magnetic domains are arranged in an orderly manner. So I am unable to increase. My maximum flux density is this much. Okay. So now what I will do? I will increase the current in the other direction. I am having a current in this direction. Now I will pass a current again in this direction. So what will happen? Now at this point, what will be my current? Current is equal to 0, right? At this point, current is equal to 0. Yes or no? At this
Yes,
point, current is 0, but I am having still some flux density inside it. Okay. Then again, when I will pass the current in the positive direction, then it is following the path E, F, and A.
Okay.
Okay. So now this completes the hysteresis. This completes the loop, and this loop is called as hysteresis loop. Understood, all of you?
Yes, ma'am.
Yes,
Got
ma'am.
it? Who was asking? You
Yes, ma'am.
understood?
Understood.
Yes.
Yes, ma'am.
So this is how we are. This is how. Now here one thing I want to tell. Why is it known as hysteresis? What is the English meaning of the hysteresis? Hysteresis means what? Hysteresis means lagging behind. This means lagging behind. B lags H. I have already discussed in the year. B lags behind H. Let us see how B lags behind H. Let us see how B lags behind H. Now look at the curve here. Here you see simple at a point I will take. Simple at a point I will take. Here you see. I am at this point. What is my value of H? H is 0. Yes or no? B is having positive value. Yes or no? H is 0. B is having some positive value, right? H is 0. B is having some positive value. Okay. So now at this point you see, at this point H has become negative. H has become negative, B has become what? 0. Okay, yes or no? B has become, at this point H is having a negative value, B is 0. Similarly at this point, okay, at any point you take, you see that B is lagging behind H. Understood?
Yes, ma'am.
Okay. So that's why it is known as hysteresis loop. All of you got it? How is it hysteresis loop? All of you
Yes, ma'am.
understood? And
Yes, ma'am.
Yes, ma'am.
you just take the values, you will see that B lags behind H. Okay. So path is completed by, what is my path? Tell me up to what the path was completed. C, D.
DEFA.
D, E, F, A. Very good. D, E, F, A. Okay.
Yes,
So
ma'am.
this is the loop is the hysteresis. It is seen that you will see that at no point the two B and H never attain 0 value simultaneously. Never attain 0 values simultaneously. Okay.
Yes,
So
ma'am.
literally the meaning is to lag behind, but B lags behind H. Lags behind H. All of you are clear?
Yes, ma'am.
Ma'am.
हाँ बोलो.
Ma'am, in the fifth point, you wrote to cancel out the residual flux density, we have to apply a negative coercive force. Ma'am, coercive force, what is its spelling?
Spelling?
Yes, ma'am.
Coercive force. Okay. Coercive force I have written here. COERCIVE. Okay.
Oh, okay.
Coercive force.
Yes, ma'am. I just
Okay. No
जेई
issue.
में पढ़ा था ना coercive force, मुझे लगा
हाँ.
same.
The value of H required, it is the force applied to wipe out the residual magnetism, or the value of H required. My force means what? Here we are talking about magnetizing force, H. Okay. Written all of you?
Yes, ma'am.
BH curve, hysteresis loop, you can write down. This is completely a theory part. Next is, today I will complete the magnetic circuit. Next is what? Next is eddy current loss and hysteresis loss. Eddy current loss and hysteresis loss. What is eddy current loss? Tell me. You have read in your ये सब 12th में तुम लोग पढ़े हुए. That is this. These are all not new things. What is eddy current loss? Tell me. What is eddy current? What is an eddy current? Suppose I am taking a magnetic material. Okay, I am taking a ट्रांसफार्मर कोर.
मैम जो फ्लक्स लिंकेज में लॉस होता है मैम कंडक्टिव.
बोलो और थोड़ा बोलो शिवम.
मैम आई स्क्वायर आर का जो लॉस होता है मैम.
नहीं आई स्क्वायर आर लॉस इज नॉट एडी करंट लॉस. आई स्क्वायर आर लॉस इज कॉपर लॉस. I square R loss, I have told you in the AC circuit also, this is copper loss. इसको मत भूलो. कॉपर लॉस मतलब ये जो है कॉपर कंडक्टर, यहाँ पर जितना करंट जाएगा इसका जो भी रेजिस्टेंस होगा ये आई स्क्वायर आर लॉस. जहां पर रेजिस्टेंस होगा वहां पर लॉस होगा, दैट इज आई स्क्वायर आर लॉस. ओके. So here I will tell you, you have approached the answer. I will not tell that you have not told. You have told. Here you see, when I am passing a current here, what happens? My magnetic flux is produced. Okay, that is passing in the magnetic core. Here the magnetic flux is produced. When this flux is linking the primary winding, EMF is induced. And when that flux is linking the secondary winding, then EMF is induced. Now here, listen to me all of you carefully. This flux is linking the core. This flux is linking the core. So what will happen? An EMF is induced in core. Understood all of you? यहाँ पर जो EMF, this one, this EMF and this EMF, both are induced in the primary winding and the secondary winding respectively. But when due to the flux linking the primary winding, EMF is induced. Flux linking the secondary winding, EMF is induced. You have not discussed about the flux linking the core. Okay. When the changing magnetic flux links the core, here I am writing, when the magnetic flux links the core, then what happens? And EMF is induced in the core. Where it will be induced? Induced in the core. Okay. So as the core is a complete path or a closed path, I can write down, as core is closed, so we are having an electromotive force. So what will happen? A current will flow. A current will flow where? Tell me, quick. Flow in core. Understood? A current will flow in the core. Here you see I am having a core. So core is my complete path. So a circulating current flows in the core like this. Okay. This current is called as a current will flow in the core. A circulating current you write down. A circulating current will flow. That means why circulating? Because that current will flow in the core itself. It will not come out of to the winding. It will not flow here. It will not flow here. It will flow in the core itself. Okay, circulating current will flow in the core, called as which current? Called as eddy current. Eddy means what? Eddy means unwanted. This circulating current is an unwanted current. Am I clear to all of you? Tell me yes or no.
Yes, ma'am.
Our core is having resistance. As core is having resistance, I have told you, if you are having current, if you are having resistance, then a loss occurs. Loss occurs in the form of heat. In the form of heat. Loss hoga to that will be in the form of heat, called which loss? Eddy current loss. Eddy current loss. Clear to all of you? Okay.
Yes, ma'am.
Yes, ma'am.
How to minimize it? Tell me. How to minimize? How to minimize it? ट्रांसफार्मर कोर को कभी देखे हो इनसाइट?
No, ma'am.
No, हाँ,
No,
no.
ma'am.
How to minimize it? You will see.
लेमिनेट कर देंगे मैम उसको.
हाँ, बस laminate कर दो. You will not take a single piece of core. What you will do it is, we will laminate the core like this. You will take small sheets. Okay, thin sheets. Okay, what we do it is, we do the lamination of the core. How to minimize it? By, if your question comes, by laminating the core. Question will come, how lamination reduces the eddy current loss? How lamination reduces the eddy current loss? You will tell that by laminating the core. Yes, tell me. By laminating, what we are doing? बोलो. ये सब पढ़े हो to 12th standard. By laminating, we decreases the area of cross section of the core. We decreases the area of cross section of core. Okay. So area of cross section of core. See here. If I am laminating, what I am doing? I am decreasing the area of the cross. Otherwise, my core area was this much, right? When I am laminating the core, my area of the cross section of the core is decreasing. Yes or no? Got it or not? So R is equal to rho L by A. If area of the cross section decreases, what happens to the resistance? Resistance will increase. Area of cross section of decreases the area of the cross section, which increases the effective resistance of the course. Effective resistance of the core. Hence, eddy current and eddy current resistance decrease होगा, sorry, increase हो जाएगा, तो what happens to the eddy current? Eddy current and eddy current loss will decrease. Yes or no? Loss will decrease. Utkal, Ashutosh, you understood? Utkal, Ashutosh.
Yes, ma'am.
Yes, ma'am.
Okay. Which increases the effective hits. Understood? Suprasad Bujela.
Yes, ma'am.
Last one is hysteresis loss. What is hysteresis loss? Just now I have told you. Just now I have explained the hysteresis. Tell me, what is hysteresis loss? You are having a magnetic material. I have told you, you will pass a current in the coil which is wound over the magnetic material. Then what will happen? Tell me.
मैम
You
एडी
will-
करंट
एडी करंट कहाँ आ गया? एडी करंट तो खत्म हो गया. एडी करंट I have already told you what is एडी करंट, how to minimize it. ये तो सब बोलती हूँ. और फिर एडी करंट कहाँ? एडी करंट को अभी भूल जाओ पूरा. अभी आ जाओ हिस्टेरेसिस के पास. बोलो. When you will pass a current inside, first in one direction, then what happens? I have told you, molecular magnets, they will be arranged in an orderly manner. हाँ या ना? बोलो.
Yes, ma'am.
Yes or no? Now, I will change the direction of the current. I have told you these two losses occurs when you are having a changing magnetic field. That means when the magnetic material is subjected to, I have told you already, subjected to an AC current. These two laws occurs when a magnetic material is subjected to an AC current. Understood? DC में नहीं होगा. Why? Because here the flux is changing with respect to time. Here also you are changing the current direction. This will only happen in case of AC current. So here you see, if I will pass a current in this direction, all the magnetic domains will be arranged in an orderly manner like this. Now when the current will reverse, then what will happen? This will move like this. Here it will be south pole, north pole. Yes or no? Tell me. This will also rotate. This one will be north pole and this one will be south pole. Am I clear to all of you or not?
Yes, ma'am.
Understood all of you? Got it? When you are passing a current in this coil, I am not getting whether you understood or not. When you are passing a current first in one direction, then what will happen? This will be in an orderly manner. North pole, this will be south pole, this will be north pole, this will be south pole, like this. Now suppose I will reverse the current direction. I will to the same one, I will pass a current in which direction? I will pass a current in the other direction, in this direction. Then what will happen? The molecular magnets will be arranged in, this one will be south pole, this one will be north pole. Yes or no? Tell me. Got it? Understood or not?
Yes, ma'am.
Okay. So what will happen? These molecular magnets, they resist fast turning in one direction than in the other. These molecular magnets are the domains. They fast, जैसे तुम लोग बस में बैठे हो, just suddenly the bus will start. Then what will do? You will move back. That is the property of the inertia. Suppose you are moving in the bus, suddenly the it will stop. Then you will fall forward. Yes or no? Same thing here. they also resist due to the magnetic inertia property. Okay, so due to this inertia, a loss occurs in the form of heat. This loss is known as hysteresis loss. Am I clear to all of you? What is hysteresis loss? All of you are clear or not? What is hysteresis loss?
Yes, ma'am.
Yes. So here I will write down what is hysteresis loss. When a magnetic material is subjected to one cycle. अब इसके बाद क्या क्लास है? मैथमेटिक्स
BMS.
BMS है मैम.
लैब है ना?
yes ma'am, welding ma'am.
Okay. Well, when a magnetic material is subjected to one cycle of magnetization, the molecular magnets or the domains, they resist fast turning in one direction, and then in the other. Okay. Due to this magnetic inertia, a loss occurs in the form of heat. Called which loss? Hysteresis loss. Okay. How to minimize it? Written all of you. How to minimize it? Tell me. Last one. How to minimize it? How to minimize it? हाँ बोलो. How to minimize it? Tell me. Hysteresis loss
Ma'am,
is. हाँ बोलो.
फ्लक्स डेंसिटी को लो कर देंगे.
फ्लक्स डेंसिटी को कैसे करोगे? वो डिपेंड्स करेगा. हाँ, you have approached. Hysteresis loss is directly proportional to area of hysteresis loop.
लूप कम कर देंगे एरिया ऑफ.
हाँ, लूप को कैसे कम करोगे?
नंबर ऑफ
टर्न्स कम करके.
नहीं, hysteresis loss is directly proportional to the area of hysteresis loop, and area of hysteresis loop is different for different magnetic material. Loop is different.
लो हिस्टेरिस कोफिशिएंट वाला प्रोडक्ट यूज करके.
हाँ बस, it depends upon the material, which material you are using. Area of hysteresis loop is different.
Yes ma'am, low quality material यूज कर सकते हैं.
हाँ, different magnetic material or different magnetic material. So your answer will be, we have to choose. So we have to choose what? Magnetic material having
area of minimum area.
Yes, magnetic material having less area of what? Hysteresis loop. You know which one? For example, तुम आयरन लोगे, उसका हिस्टेरेसिस लूप इतना ज्यादा नहीं. सिलिकॉन स्टील लोगे, इसका एरिया ऑफ हिस्टेरेसिस लूप बहुत कम है. Understood? So we have to choose magnetic material having less area of hysteresis loop. Complete?
Yes ma'am.
Those who have written, complete, no doubt, you leave. You are having class, you leave.
Yes ma'am.
Thank you ma'am.
Thank you.
मैम मैं लेट हो गया।
लेट ज्वाइन किया था।
Thank you, ma'am.
मैम कैन आई आस्क अ क्वेश्चन?
हाँ, यू कैन आस्क।
मैम कॉलेज जाने के बाद फ्रेशर्स होगा?
क्या होगा?
फ्रेशर्स?
वाह
सुनाई नहीं दे रहा।
यस मैम, ये डाउट
मैम फ्रेशर्स पार्टी
फ्रेशर्स हो गया, सीनियर
हाँ,
हो गया,
मैम।
फ्रेशर्स।
मैम
मैम हम लोग को मिला था मैम।
हमको मिला
मैम
नहीं है।
12th का फेयरवेल भी नहीं मिला, फ्रेशर्स तो मिलना चाहिए ना।
फ्रेशर
Yes.
तो बहुत अच्छी तरह से होता है सबसे। सेकेंड ईयर का
मैम
फंक्शन
क्या फायदा होने का जब हमको ही नहीं मिला?
अरे तुम लोग कर सकते हो, तुम लोग तो तुम्हारा ही फंक्शन है। फ्रेशर्स पार्टी तो फर्स्ट ईयर का नहीं है, फ्रेशर्स पार्टी तो सेकेंड ईयर का है ना। सेकेंड ईयर ही परफॉर्म करते हैं, फर्स्ट ईयर लोग सिर्फ बैठ करके देखते हैं। फ्रेशर्स पार्टी
मैम।
जो है ना, दैट इज द फंक्शन ऑफ सेकेंड ईयर ओनली। तो तुम लोग सेकेंड ईयर हो जाओगे तो तुम लोग दोगे ना वेलकम जो दोगे
मैम
फर्स्ट
लेकिन हम लोग को भी देखना था मैम, थर्ड ईयर
मैम
वाले लोग
हमको तो नहीं मिला, हम फिर क्यों देंगे?
तुम लोग यार सोचोगे तो क्या, पर फ्रेशर्स पार्टी तो सेकेंड ईयर का ही फंक्शन है, बहुत अच्छी तरह से होता है फंक्शन। तुम लोग का पूरा मतलब क्या क्या पूरा एक एक चीज तुम लोग का पूरा हो गया, खत्म हो गया लाइफ में, वो नहीं मिलेगा। नहीं,
मैम हम लेके रहेंगे।
मैम छीन लेंगे हम।
बोर्ड एग्जाम नहीं दिए, फेयरवेल नहीं मिला 12th को।
मैम बोर्ड एग्जाम ठीक था मैम, नहीं
हाँ मैम, हम लोग सबसे अनलकी भी है। मैम लेट ज्वाइन।
Lock
मैम
किया।
सेकंड ईयर में आके हम अपनी पार्टी करेंगे फेयरवेल।
फ्रेशर्स पार्टी नहीं मिला, और इंजीनियरिंग का एक साल फर्स्ट ईयर तो मेन इंजीनियरिंग लाइफ को एंजॉय करने के लिए, वो भी खत्म हो गया। पूरा बेकार लाइफ, चलो चलो बेकार लाइफ।
मैम लेट ज्वाइन मैम।
लेट जन, हाँ हाँ
लेट जॉन भी बेकार लाइफ है।
हाँ।
थैंक यू मैम।
मैम नेट प्रॉब्लम था इसलिए लेट ज्वाइन किया आज।
थैंक यू मैम।